even though I've been talking about primes a little bit so far, let's give it an official definition. Okay, so a prime number is a number. Why is this unhappy with me? Sorry. A number greater than 2 whose only divisors or factors are 1 and itself. Okay, the number 1 is actually considered neither prime nor composite. Same thing with 0. 0 is considered neither prime nor composite. And then it's understood that when we're talking about prime numbers, we're talking about whole numbers. Okay, so here's going to be some open questions that we're not going to answer all of these right away, but these might be things that you could think about. Um, so much of math involves formulas, patterns, predictability. Okay, so as we start looking at all the primes between 2 and 100, we're going to be considering, are they occurring in a predictable pattern? Okay, is there a formula for them, right? So much of math involves formulas. Is there a formula that will generate the prime numbers? We also want to know if the number of prime numbers is infinite or finite. Okay, think about what would your intuition say about that? I mean, we know our numbers go on and on and on forever, right? We can continue counting with no end to that. So do you think the number of prime numbers would have to be infinite? Or do you think we could find some prime number that's like it's the biggest prime number there is and then there's no more? Okay, so what does your intuition say about that question? And then finally, we're going to answer the question and we're going to look at how our national security relies on really big prime numbers. A lot of you marked that as one of the things that you were interested in learning about. All right, and so I've got a cool activity related to that at the end of this segment. So before we can get to that cool stuff, we have to learn a little bit about primes. All right, so in order to find all of the prime numbers between 2 and 100, this is how we're going to do this. Okay, I gave you a chart of all these numbers up through 100, and every time we get to a prime number, we're going to circle it. Okay, so 2's prime. But then what we're going to do is any number then that is divisible by 2 can't be prime, right? Because it has 2 as a factor. Okay, so after we circle the prime number, we're going to go through and cross out all multiples of that number. What's nice about this chart is we can cross out entire rows here, right? All of these, actually these aren't rows, these are columns. All of these columns of even numbers can get crossed out. So I hope you have this printed and that you're playing along with me. Okay. The next prime would be 3. And then any number with 3 as a factor has to be crossed out. So if I just start going every 3 numbers, right? 1, 2, 3. Well, 6 is divisible by 3, but it's already crossed out, right? 1, oops, sorry, I didn't mean to do that. 1, 2, 3. Okay, 9 is divisible by 3, so we cross it out. Okay, so we keep counting. 1, 2, 3. All even multiples of 3 are already crossed out. 1, 2, 3, so I can cross out 15. Okay, so play along with me. Keep counting every 1, 2, 3, and if it's not already crossed out, then cross it out. So I have just crossed out, or I'm almost done crossing out, every number that has 3 as a divisor. Divisor and factor are the same thing, right? So every number I crossed out is divisible by 3 and therefore can't be prime. Okay, now I circle 5, right? But then I get to cross out, this one's easy, right? The whole row, all multiples of 5, right? Every fifth number. These multiples of 5 are already crossed out because these are multiples of both 5 and 2, right? If I did a prime factorization on everything in this last column, I would see at least one 2 and at least one 5 in every single prime factorization. Okay, so then I go on to 7. Okay, and then I have to cross out, and as I go further and further, more of these numbers are already crossed out. All right, so if I start counting by sevens, right, 7 plus another 7 is 14, already crossed out. 7 plus another 7 is 21, already crossed out. All right, 7 plus another 7 is 28, crossed out. 7 or 28 plus another 7, 35, already crossed out. You might feel like, okay, are they all going to be crossed out? Right? 35 plus another 7 is 42, crossed out. 7 plus another 7 is 49, right? So that one's got to get crossed out. So you will cross out a couple, right? Most of them are already crossed out. And I'm going to tell you to pause the video and keep going until you're done. And figuring out when you're done is a math problem in and of itself. Okay, trying to decide, when am I done? Okay, so if you're rejoining me, I didn't give you a lot to do on your own, did I? All right, because you should have realized, since we've already done up through multiples of 10, right? By the time I get to 11, I would have already paired 11 with all of the numbers in this first row, right? I've already got 22, 33, right? Because that's divisible by 3. 55, right? 77, right? I would have 88, that's already crossed off. 99, already crossed off. 110, that I'm too big for this grid. Okay, so that means that everything that remains, that's how I know I'm done, right? Everything that remains has to be prime. So I have a list here now of all prime numbers between 1 and 100. Okay, and so I want you to look at this and think about, are they occurring in a nice, predictable way? Is there a pattern to these? All right, and I hope you stare at them for a while and think about that. Okay, we'll talk more about this in a separate lesson. So we'll end here for the moment.